All right, here we are. I'm going to share my entire screen. We're back.
Share your life.
Share my life. Here's my life. This is what my life has become.
Road.
We're going to talk about OAuth. So we have here a very basic OAuth server. This is a simple Go app that I wrote just now. It has a beautiful homepage, and
How long did you spend on this?
About 20 minutes.
Wow, that's pretty impressive. Did Copilot write the whole thing for you?
No, there's a lot of copy paste. All right, so I'm going to log out. As you can see, there are no cookies here. What this thing allows you to do is log in as Matt.
What?
And I should be logged in as Matt. All right, good. I can log in, I can log out. Very simple web server. Now, what is cool about this is that this is actually an OAuth provider. So I can sort of demonstrate like how OAuth, hopefully, how OAuth works a little bit. And what we're going to start with is kind of an overview. So basically OAuth is a sort of a protocol for negotiating authentication between a provider, which is like the service that is responsible for the authentication, and some kind of client service, which is going to sort of delegate the responsibility of authentication to the provider. So in a traditional web app, you're going to have like, you are your own provider and client. You authenticate users maybe by like email by doing email verification, and then once you authenticate them or have them sign up or whatever, then and sign in, then you do some kind of like cookie based maintenance of their session based on that authentication. In OAuth, you're sort of like letting the provider deal with that part of things, and you then ask the provider what user this is. So you're saying basically like, go log in on this provider, and then when you come back, the provider is going to tell me, the client service, exactly who you are, and then I can decide whether you have access to my service based on that authentication. So it's like, if you're thinking about like authentication versus authorization, where authentication is like who you are, and authorization is what you have access to, you're delegating the authentication piece. Any questions, or was that reasonably clear?
Yes, reasonably clear.
All right, so how does OAuth work? There's a pretty good site called like Oauth.org or something like that that kind of talks through like in much more detail. But basically, OAuth is built on top of HTTP, or at least most. I assume all OAuth variants are sort of built on top of HTTP, and it's sort of a way for two HTTP servers to exchange information about the user. That is actually, that's not even quite true. It doesn't need to be a client does not need to be an HTTP server, but very often it is actually two HTTP servers that are exchanging information about who the user is. So there's a client, typically a client, web service, but it could be like a mobile app, and like an OAuth provider service, and there's basically a sort of negotiation that happens such that the user gets directed to the provider, performs authentication, and then gets directed back to the originating client service. And then the client in that redirect back will be provided with some information about how to then figure out who the user is. So in practice, what this means is, we're going to do this live because I haven't actually done this part, but first we're going to verify that this thing is working. Can everybody see the curl here? The curl command?
Yep.
Okay. So curl, when we're going to first log in. Actually, we're not even going to log in. We're just going to pass a cookie, which will indicate that we are logged in. So set cookie. Let's just do it however we did it here. No, we want this one. Where is the request? All right, we want this header cookie. That's pretty easy. And that will be sufficient for us to be logged into this service. And what we're going to do, I'm actually going to print out more stuff here. And I'm going to do Oauth Authorize within a logged in state. Not found. Sweet. So Oauth 2 is at Oauth 2. All right, we did a bad request. So what the this is the first endpoint that's relevant for OAuth, is this Authorized Endpoint. When we send the user to the Authorized Endpoint, typically they're going to be presented with like something along the lines of like this, like a UI that's like, whatever, AirQL is asking for permission to use your identity. So you've seen, I'm sure you've seen that a million times with like Google login for some other like third-party service like Linear or something like that. The actual endpoint you're hitting on Google there is the Authorize endpoint, what's known as the Authorize Endpoint. This is where the provider can present you with a UI that's like, do you give this service permission to like, act as you on their service? So there's a few things that Authorize requires, and Authorize. I am going to look it up. Grant type. Okay. So here we go. We want actually authorization. Here we go. The request, the response type. So this is the type of basically the kind of token that we want from the provider. So in the case of the authorized endpoint, it's typically, or maybe always, code. I'm going to do this because these are bothering me. So it's going to give us a code. We're going to say, actually, we're just going to ignore the client. No, we're going to set a client ID as whatever, DRAT. And optionally, we can set a redirect URI, a scope, and a state. And I'll get into those in a second. But I think that, the hell, man. Oh, good. Good. Invalid. Here's where we get into the good part, me debugging. Generate auth token. Okay, so it was kind of working.
Get angry. I want you to get angrier. More rage.
More feeling.
Yeah, more feeling.
I think that I need to look at this for a second because I think I'm missing the I'm missing the client ID. Oh, models. Yes, this is what I'm missing. Okay. So the front end OAuth client gets used. Oh God, okay.
Quick question, is this making your service a provider for others to log in via OAuth type thing?
Yeah, exactly. So this is like what, a provider like Google or Twitter or whatever would be implementing. They would probably be implementing it in a way that wasn't crashing. But otherwise, like this is sort of the essentially what they're doing. Will this work? No, I don't want that. I want models. Okay. Front end OAuth client. And I don't care about this. Context. And I'm going to return, I think there's an easier way to do this, but call this DRAT, we'll call domain sure. And the client ID. Okay. I don't think I actually need that. All right, so the store will the domain secret will be empty. And we're going to front end OAuth client. Where the, oh yeah, okay. So this thing just returns this client info, which is, I think, this thing. So we're just gonna, okay, I think we had it. Okay. That's what this is going to return. This is basically a way for clients to identify themselves. And I need to put this somewhere, client store. Here we go. This is the stuff right here. Why? An unfilled store. Oh, yeah, you're right. Okay. All right. So rebuild. Now we're gonna try this again. We go to found. All right. So we got somewhere. So what this did, I curled for the to this authorized endpoint as if I was navigating there in a browser, and what it sent back was a redirect, which was to my say my services domain. So say localhost 3000 with a code, and this code is not. It's not actually an auth token yet. The token is what we're trying to get to. The token then allows us to basically access user information on the provider, or otherwise access resources on the provider. But there's sort of multiple different kinds of tokens. And the first one is the code, and we use this code to exchange for an access token. So generally, you would be sent back to the client service, and you would end up on some endpoint like whatever auth/Google/access or something, and then the client service reads this code from the URL and then makes another request to the provider, but this time accessing the token endpoint with grant type equals code, and I think response type equals response type. Well, we'll try it. Response type equals token. And we are going to We don't need this cookie any longer. But we do need code equals this. All right, so let's see what this returns. Oh, unauthorized, I didn't like it. I think I'm not making quite the right request here. Access token request, grant type, authorization code. No response type. Yes, client ID, and yes, code. What did I do? Client ID, code. Invalid request. The request is missing a required parameter. I think it's the redirect URI. There we go. Okay. So, so we made a second request to the provider, and we included the code that we got in the redirect. And this time we got this JSON blob back in the body of the response, which has an access token and a little bit more information about that access token. So with this access token, we can actually make requests to the provider, passing it as an authorization token, or as a bearer token in the authorization header. The provider will know that the client is acting on behalf of that originating user. So that makes it so that, for example, like usually there's another step at this point, which is to fetch user information. One sec, Gabriel. To fetch user information, and so you'll make a subsequent HTTP request to determine the, for example, the display name or the email or the avatar image, those kinds of things of the user. You can also typically, depending on the scopes you requested initially, you can also access other provider resources on behalf of that user. So yeah, Gabriel.
Cool. So my question here is more in terms of why that code exchange step is required. And I assume it's from a security perspective, right? So in practical world, you would probably have client ID be a secret or something like only the app owner knows. And you can't do phishing and pose if RQL is authenticating as Google in Google, you can't make a phishing RQL to authenticate in behalf of RQL because the attacker won't know RQL's actual secret client ID there. So I imagine it's difficult that process, but I just want to confirm if that's the purpose of that extra exchange phase, because technically you could just respond the JSON from the first request, but we don't do that.
Yeah, it's a good question. You could be right. I don't know exactly why that is or what attack vector is being sort of bypassed. Technically that code could just be an access token, right? There's sort of, you could imagine the protocol being designed that way. I'm not 100% sure why there's this sort of two-way thing. Definitely part of it is you do want to, the secret comes into play here. In this case, the secret is that there is no secret, but like the secret was empty, just the empty string, so it didn't matter. But like there are, there, like if you have a like a web app that has no server side, then you don't actually pass the secret at any point during the back and forth, because like otherwise you'd be exposing the secret to the browser. So it's not exactly, I don't think it has to do with the secret exactly, but I'm not exactly sure why there is. I'm sure there's some kind of attack vector in there that I haven't really thought through, but
yeah,
it's a good question.
I imagine it's something related to that. Like even if it's not using the secret, if you're in a browser, you could use like the domain to validate the two requests. It's coming from the same domain, it's the same origin, like from the same IP, something like that.
Yes, that's right.
Maybe it's something like that, because it's curious, right? Like it's curious why make this extra request necessary, and I imagine it must be something around security wise, because otherwise it's just like extra pain.
Yes, completely. Yeah, so there's other things in here, like, on the topic of security, there's some stuff that we didn't actually talk about, but in the original request, you can actually specify a state parameter, and when the redirect back to your server happens, it will include that state parameter in the URL, so that basically you can ensure the way this is typically used is like you set a cookie with some random state value, and then you send the user through the redirect with that same state value, and when they come back, whatever's in the cookie should match what's in the URL. Otherwise, somebody else is trying to somehow interject into this, like there's some kind of like man in the middle here. So like basically the idea is like only the provider and the client know this shared state thing.
That's very interesting.
Yeah, so there's like a bunch of sort of things like that. There's also like variations on this flow. Like this is, there's sort of like different kinds of sort of tokens. So you might have noticed that in the response here, there's actually a refresh token. So the access token, as it says here, expires in 7,200 seconds, and after which that access token will no longer be valid. The refresh token lasts longer, and you can use that refresh token to request a new access token, but you can't actually use that refresh token to like, for any other purpose. It's not a general purpose access token.
And again, this is about security, right? Because if there is a man in the middle attack and they request your access token in any given request, they only have access for limited amount of time.
Exactly.
So they would need to be a man in the middle attack in the actual request where they have the access token and the refresh token to be able to do a bigger damage. And it's interesting because this protocol is so open in the web, like it's just exchange of information via URL parameters.
Yeah.
And technically it's unsafe to do stuff like that. And it's interesting to see these layers of safety in exchanging information via just GET requests here and go back and forth. Like it's very interesting.
Yeah, yeah. And I mean, this all relies on, like sort of like SSL between the, you know, in these requests. Like there's like a lot of sensitive information sort of going back and forth for sure. So I'll talk about a couple of other things quick, but any other questions at this point? Does this sort of make sense? Anything unclear at this point?
Where do you set the scopes?
Yeah, so the scopes are part of the initial authorized request. So you would include that, I think it's scope or scopes. You would include that here.
Sorry,
So
I mean,
it might be.
I
Oh,
mean,
sorry.
like on as the provider itself, like how do you like limit the scopes to whoever's calling on that? Like for your service, let's say DRAT, I only want them to access, you know, name, this and that, but they can't access everything else. How would you, like, where in the code do you do that?
Yeah, so so the way that it works is that on each authorized request, the client specifies what scopes they're interested in, and the provider will then show the user like, hey, this app is requesting access to your email, your calendar, your whatever, you know, all the things that it will give access to on the provider side. So if the client hasn't been configured for accessing those scopes, then like that's one place that the provider could like deny access. If the client was set up to access those scopes and the user does authorize it, then the returned access token, like ultimately the returned access token is going to sort of have information about the scopes, or there will be scope information associated with that access token. And then on each like API request to the provider, you know, the scopes can be checked to make sure that you know, that's sort of like the request is within the limits of the scope. So the way that this Go server works is it uses this this OAuth 2 library. This library basically stores access tokens in Redis. So if we want to take like a little detour, do I have Redis? Oh shit, I don't know if I do. In any case, like basically every time it grants an access token, it stores it in Redis along with some information about what that access token represents, and the scopes would be part of that extra information.
Okay, thanks.
Other questions? So that's kind of the most of what I wanted to talk about. You know, this kind of hopefully gives you a sense of like what an OAuth server or provider looks like. You know, generally an OAuth provider is doing more than just actually like sort of authenticating a user, but it's actually like in the case of Google, it's like there are other APIs that are then accessible to the client app based on the scopes that are available in the auth token. And so, you know, that there's sort of like, you know, a bunch of things you can do with that. Like, for example, with AirQL, once you, we basically just use it to determine the email address, or to you know, decide whether the currently logged in Google user has a particular email address, and then use that to gate permissions gate access to like Airtable resources. So there's, you know, lots of sort of different ways to do it. On Please Review, we use GitHub OAuth, and then every API request we make to the GitHub API is basically forwarding along this access token that we got on the initial login, or from a refresh token. So OAuth, like, kind of, it's all kind of all over the place. Like, we use it everywhere, and so it's pretty important to like kind of understand what's going on under the hood there. But hopefully this helps.
This was helpful. Like, I knew about this and had used OAuth a lot of times before, but I didn't know it was a formalized protocol with defined requests and defined response. I thought it was just like every provider implements its own version and kind of the community going the same place. I didn't know that was a specified protocol. Interesting to know that.
Yeah, there's a, like, the spec is actually reasonably accessible. Like, it's not, you know, it's not terribly long or complicated. And the core of it really is this, you know, for most use cases anyway, is really this, you know, part 4 or section 4 or whatever, that kind of like walks through the whole sort of process and how that works. And then, you know, every language has its own client and server implementations. It's pretty uncommon to actually need to implement a provider, but you know, implementing like client like we do it all the time. So we also have a library here for Remix that supports Google and generic OAuth providers, that basically does authentication via like OAuth providers. So if you're writing a Remix app with OAuth, that's an option.
That's cool. That's cool. Yep. Thank you so much, Dylan. This was very helpful.
Julio. Any other questions? All right. Thanks, everybody.